Okay guys, so the final thing we're going to talk about for today is the hyperbola, and that one has actually two different formulas. Notice in this one x comes first, and this one y comes first. When x comes first, we have our sideways parabolas that look something like this, and then we have our vertical parabolas that look something like that. I'm calling them parabolas, obviously this is called a hyperbola when you have both of them. But they have two different equations, and with those two different equations, you get two different looking graphs. It's kind of easy to graph these actually. I learned a trick dealing with A and B, and I'm going to show you those right now. So, first one we're going to graph. We know this is a hyperbola and not a parabola, or I'm sorry, and not an ellipse because this is minus. Okay, so when that minus is there, we know that. Here we have h and k. That's 0, 0 still. Okay, in this case, a here, or a squared, is equal to 4, so a is 2. B squared is 4, so b is 2. And then it's equal to 1. So here's what we're going to do. We're going to take our graph. Okay, we'll do our best. Let me do it a little bit further. So we've got this. Zero, 0. And then what we're going to do is a is 2, so we're going to count up 2. I'm sorry, no. In the x direction, 2. 1, 2, put a point. 1, 2, put a point. B is 2, so we're also going to count up 2. 1, 2, because B is 2. 1, 2. And then what we're going to do is we're going to make a square out of this. This square is going to help us draw it. Okay, so now that we've got this square, what happens with a hyperbola is this square tells us where the asymptotes should be drawn. So if we use a ruler, what I can do, I'm going to do my best here. So to match that corner up. Do my best. So we've got that. Okay, and so from here we can draw an asymptote. And we can do another one, this time going this way. Okay, we'll just do our best. We've got an asymptote going like this. Okay, we no longer need the ruler. And from here, we know that because x squared comes first, it's the positive value, we are looking at a graph like this. So, how this works, this point here, A, I'll put it in red, and this point here, A, turn out to be the vertices of the parabolas. And so from there, we're just going to draw a parabola that extends towards the asymptotes. And that graph will be the graph of the hyperbola. And so it's not too tricky. Takes a little bit of practice. You just have to know how to draw the box. And once you draw the box, you use it to make the asymptotes at the corners of the box, and then you just fill in the parabola based on, or I'm sorry, the vertices and the parabola based on what is the positive value, the x or the y. Let's go on to the next example. So in this case, we have h is -1, it's with x, k is 2, and a here, a squared, is equal to 1, so a is 1. B squared is 4, so B is 4. Notice, I'm sorry, B is 2. Notice that A is still under X, and B squared is still under Y. Okay. Now, here we go. We're going to try to graph this. We've got a line. We've got another line. We've got our center. The center is here at -1, 2. So we go to -1, up 2, We put our dot. Okay. Our y value comes first, so our y is where our vertices will be. So we're going to go up 2, 1, 2. That's our vertice. Down 2, 1, 2. That's our vertice. And then for our x's, we're going to go 1 to the right and 1 to the left. We've got those 2 points. We're going to draw our square to the best of our abilities. Okay. I don't know why it didn't like that. Let's do it again. See if it makes it nice. Nope. Whatever. We'll use our ruler just to make it a little bit cleaner. Okay, so we're just going to go something like the following. There's 1. Okay, here's 2. We know our vertices are right here and here, so we'll just fill in the parabola as follows. Here's 1. Here's 1. Here's 1. Here's 1. And that is our graph of the hyperbola. Okay. Now, obviously, it could be the case that we have a problem similar to the last one that I did on both the other examples, but in this case, and we would complete the squared as we normally would. But since this section didn't have any examples like that, I'm not going to give you one for this, for the homework. The only thing to do on this problem is divide by 16. Okay, this is going to give us x plus 5 squared over 16 minus y squared is 1. And so here h is negative 5, k is 0, a squared is equal to 16, so a is 4, b squared is 1, so b is 1. We're going to go ahead and try to graph this now. Okay, we've got negative 5, 0. Uh-oh. I'm going to need more space, I think. So let's do this again. Okay. Negative 5, 1, 2, 3, 4, 5. We've got our point. That's our center where we're going to start the box. We have a is 4, so we're going to go 4, 1, 2, 3, 4. 1, 2, 3, 4. That's our vertices because that's the x. Our y is 1, so we go up 1, down 1. We draw our box. It's nice to have graph paper for this. Okay. Then we take our ruler. We're going to do our best. Here we go. Okay, here we go. There's 1. Obviously, guys, you're just going to try to do your best. If you don't get it, that's fine. Just try to get it close. And then, like this, and this, and that, and that. Reason I know it goes in the x direction, obviously, is because x was the positive value. So if you look back at your notes above, you will see when x is the positive, we have a shape like this. When y is the positive, we have a shape like that. Okay. I hope this helps. Obviously, ask me questions if you have them. This is kind of like a quick lesson. We did not talk about the focus. We did not talk about directrix. We did not talk about anything like that. Although that is common to be talked about when you speak about conic sections. However, since our book does not seem to cover it, I believe it must not be part of the curriculum for intermediate algebra, possibly. And so, does it not? Yeah, none of the, well, at least none of the example problems have it. And the book might talk about it, but it doesn't have it in the examples. So, that being said, thank you guys for watching. If you have questions, don't forget to ask. Keep doing your best, and email me if you need anything. Thank you.